Everyone, welcome back to the channel. In this series, we are looking at Leetcode problems, and today we are looking at Leetcode number 42, trapping rainwater. This is similar to the container with most water problem, and I would suggest doing that one first just to get a better idea of how we are handling this problem. This one states, given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water can trap after raining. So we're given this array of integers representing heights, and instead of returning like the max area, they want us to return every amount, every space that can hold rainwater. We're not doing it here or here because there's no edge. They just only if there is like another block or height here. And the way that we're going to keep this algorithm optimized and similarly to the way that we handled the container with most water, we're going to use the two-pointer approach using a left and right pointer. And they're going to work their way inwards towards each other. And we'll keep track of the max height that we've seen on both sides and use that as a way to calculate the space that we have between each of our heights. And as we iterate through that, we will update the max height. So there are a few variables that we're going to keep track of, but still it's keeping our space complexity low because we're not using any additional data structure other than a few variables. So the first variables I want to make is my pointers. So I'm going to make a left and a right. And they will be initialized to each end. So my 0 index and my last index. And then I want to return water, and this is what I'm going to keep track of as the water amount. And like I said, we also want to keep track of the max height that we've seen so far on the left and the right. So I'm going to make a left max set to 0, and a right max set to 0, and update that as we move along. And since we are using the two-pointer approach where they are going inwards, we're going to add the condition that while our left pointer is less than right, and as soon as they meet in the middle or they cross, we can exit from our while loop. Now, once we're in our while loop, we're going to want to check either side. So you can do this in either order, but what I'm going to first check is our height of our left pointer less than the height of our right? And if so, we'll process the left. If not, we'll process the right. So to process the left, first I want to check if the height of where I'm currently at, if it's greater than what we've seen as our left max. So the height at our left pointer, is it greater than or equal to our max left? And if it is, then we need to update our max left to be the current height since it's no longer the highest. Otherwise, we want to use that distance or the height distance to increase our water amount. And that would be our left max minus the height of where we're currently at with our with our left pointer. And then once that is done, we'll increase our left pointer. And this processes the left and moves our left pointer forward. So now we need to do the right. And we'll basically do everything here except with our right. So now we want to say, is our current height at our right pointer greater than or equal to our right max? If so, we want to update our right max. Otherwise, increase our water amount to be equal to the right max height minus the height of where our right pointer is at. And then in this instance, because our right pointer is moving to the left, we want to decrement our right pointer. And this will allow both of our pointers to work their way inwards and to calculate all the spaces that exist in between our heights. So eventually they will meet in the middle and we can exit from the while loop and return our water amount. And I know that some of these variables can have similar names, so just be careful that you are using the correct variables. And as you can see, our test cases passed for this. Again, this is an O of n time complexity since we are only iterating over our array once, and an O of 1 space complexity since we are not creating any additional data structure. We're not using a stack in this instance. And that is it for this Leetcode problem. If you have any questions, feel free to comment below. I'd love to hear from you, and I will see you in the next video.